welcome Harshit Sir. And Sir always accepted our invitation whenever we have called Sir for their expert session here at Charusat. I think this is the fourth time Sir is here to deliver a talk over the AR VR. Sometime on Vuforia, sometime Unity 3D Blenders. And Sir is the CTO and founder of Hash Media at Ahmedabad. Sir has vast experience in the virtual reality and its development. Is working in the same field for the last approximately 10 years, roughly. And Sir has very vast experience in the industry mode of development. So I request students also that whatever doubt, whatever you want, you can ask, how much you can learn. Please be proactive and interactive during the session. So I request Harshit Sir that please start the session. If anything required from our side, then please Sir let me know.
Yes, I cannot share my screen right now.
Just I am
Only
making
me.
you the presenter. You are now
Okay,
presenter, sir, and you can do this.
sure.
Now you can check, sir.
Yeah, just a second. I just have to disconnect one time and I will rejoin again.
Okay, no issue, sir. No issue.
Yeah.
Now I
Okay.
am making you presenter, sir.
ठीक है, ठीक है.
Now you may start, sir.
Okay.
You share your screen, sir, so I can acknowledge you.
Okay.
Yes, sir. Now visible, sir. Your screen is visible.
Okay. Okay.
Okay, sir. Okay. Thank you, sir. So this is our sixth semester student, so they required something from basics only. Okay, sir.
Okay. Okay.
Thank
Okay.
you. Thank you, sir.
Fine.
Please.
And yeah. Okay. So, good morning, all of you. Sorry for the delay. It's a curse of work from home now. So, internet issue and everything. Yeah. So let's start. So, as Sir has told me that you are all of six semester student. So probably you are through with your computer graphics subject. I'm hoping that. So we'll start development and Unity 3D. Okay. So today we are going to cover these topics. Okay, the first is history of 3D software. The second is introduction of basics of 2D and 3D computer graphics, where we can explore some theory about 2D and 3D computer graphics. Then we will move to introduction to basics of Unity environment. We will go through the UI, and what are the different modules are there which we can use in Unity 3D. Then we will create our first Hello World application in Unity. Then we will see little bit of scripting, the basics of scripting, how we can script in Unity. Unity uses C# as a scripting language. So we are going to explore C sharp little bit. Then we will develop one small game. So Unity 3D is basically the game development engine. So if we are not building a game while learning the Unity 3D, then there is no use of Unity. And then if time permits, we will create small VR application in Unity 3D. All right. So let's move towards our first topic, history of 3D softwares. Okay. In the past, 3D softwares were invented to support engineering drawings or for CAD or CAMs. As you know, if your fellow mechanical engineer students are using AutoCAD, right? So, and they developed different engineering drawings on AutoCAD. So, in the past, the necessity was that the engineers want to draw different types of drawings on the computer. So they invented a 3D CAD CAM software. So the first 3D CAD CAM software was invented in 1980, was called Rhinoceros. It uses the nerves based modeling software, and it was a commercial software. So it was the first commercial software which dealt with the 3D stuff. And Rhinoceros was mainly used for its speedy modeling workflows. Okay, and it uses C sharp and Python as a programming language. It is still there. These are the list of software which are still all the which are here in the market, and it is still serving the customers and 3D modelers. So the second is Autodesk AutoCAD. This is the famous one. It is a commercial CAD software and drafting software. With the passing of time, 3D workspace and modeling tools are introduced in the latest release. So it was introduced in 1982. So basically, AutoCAD is very famous software, and you can draw CAD CAM drawings. And many architectures, engineers are using it for the drawing of a 3D model. Okay. The third one is Cobalt, which was introduced in 1988. It is one of the earliest parameter based CAD programs and 3D modeling tools. It is also still here right now. The fourth one is Cinema 4D. It was introduced in 1990. One of the earliest 3D animation and movie making software, which is used for its effective workflow, advanced feature, and good rendering quality. As you see, the evolution is happening in 3D software. So first it was only used for CAD CAM drawings. Then we are moving towards entertainment industry. Cinema 4D was introduced, so you can make a 3D animation and movie. And after that, the very famous one, the Blender was introduced in 1994. Blender is freely available for all the platforms which are known for its animation ability, simulation, application of visual effects. This software was used in Captain America, the Winter Soldier, Annabelle, the Creation, and Wonder Woman, and Cinderella the Cat, etc. It's still using it is still used in the movie industry. It's a very famous software, Blender, and it was introduced in way back in 1994, almost 30 years ago. The sixth one is Autodesk 3ds Max. That was introduced in 1996. It was a professional 3D graphics, modeling, animation, and game creation software which was used in developing several TV commercial ad, games, and animations. So this is also a very important one, 3ds Max. And after that, Autodesk introduced Maya in 1998. Professional 3D graphics, modeling, animation. Same. What you could do in 3ds Max, you can also do in Autodesk Maya. But one difference was you can generate 3D video, which is very complex to do in 3ds Max. So Autodesk Maya gave a very easy way to generate 3D videos. And at last came the Unity in 2005. That Unity is an engine, can be used to create 3D and 2D games as well as interactive simulations. The Unity has been adopted by industry outside video gaming, such as automotive, architecture, engineering, construction, and more other industry. So here are the few of the example. There are other software as well right now in the market, but these are the famous one. So the his evolution has come a long way for 3D softwares. You can learn any of this software and you can build your career in any of this. It's a very big opportunity. For example, if you know how to create 3D videos and 3D models in Autodesk Maya or 3ds Max, the pays are very high, salaries are very high. If you are master in that, you can be a good 3D developer and you can earn very much in this field. And right now there is a shortage of 3D modeler or 3D developer in the market. So you can definitely build your career in any of this 3D software. So this was the history. Now let's move towards introduction to basics of computer graphics. Okay. So there are basically two types of computer graphics. One is 2D graphics and the second one is 3D graphics. Okay. So what is 2D computer graphics? So now 2D computer graphics is the computer based generation of digital images. It is mostly generated from two-dimensional images using techniques or to the model themselves. So basically 2D is just the image or graphics which are in two-dimensional, which uses two axes only, x and y axis. That is 2D computer graphics. So as you learn, if you have learned the subject computer graphics, then you already know the application of mathematics go side by side with the computer graphics. So you have to know the basic mathematics to learn computer graphics. Okay. So now where do 2D computer graphics apply or we can use it? Now 2D computer graphics are mainly used in applications that were originally developed upon traditional printing and drawing techniques such as typography, cartography, technical drawing, advertising, etc. So if you are using DTP application, desktop publication application like PageMaker or Corel Draw, okay, then it's a 2D computer. You are generating 2D computer graphics. Now, this now the next topic is different operation in 2D computer graphics. Now, this operation, if you have learned the subject, then you have to know you there are three operations in 2D computer graphics. The first one is translation, the second one is rotation, the third one is scaling. The first operation is translation, where you move any 2D object from one place to another. Like if you imagine that there is a Cartesian system with two axes, x and y, and for example any object is on 0 0 coordinate and you have to move to 5 5 coordinate where x is 5 and y is 5, then then this thing is called translation. This operation is called translation. You are moving 2D object from one place to another place, so this thing is called translation. The second one is rotation. you are rotating 2D object at some degree, by some degree, like 90 degrees to 70 degrees, like that. So that is called rotation of 2D computer graphics. And the third one is scaling, where you are increasing the size of 2D object. So you are making two times bigger than the current one. So that is scaling. You can scale up and scale down. In scale down, you are reducing the size of 2D object. And this operation is also used in 3D also. So the concept are same. Only in 3D, only you are increasing one extra axis, which is called Z axis. So 2D is X and Y, and 3D is X, Y, and Z. So operations in 3D are little bit more complex than operations in 2D, because we are introducing one more axis. Okay, and the example of 2D graphic software, the Adobe Illustrator or Adobe Photoshop are the very famous example. So these were the 2D graphics. Now we are moving to 3D computer graphics. 3D computer graphics, or that is called three-dimensional computer graphics, are the graphics that uses a three-dimensional representation of geometry that is stored on the computer for the various purpose. So now we are introducing one more axis, Z axis, and we are creating the 3D model, and we are storing on the computer for various purposes. The objects in 3D computer graphics are often referred to as 3D models. Unlike the rendered image, like in 2D graphics, a model's data is contained within a graphical data file. A 3D model is a mathematical representation of any three-dimensional object, and it is not technically graphic until it is displayed. So that is the catch. You are storing just point data and their coordinates into the file, and when it is rendered on the computer screen, then it becomes 3D model. Okay. Okay. So the next is workflow of 3D computer graphics. Uh, the workflow of generating 3D computer graphics. So now there are three steps are involved in the workflow. So first you do 3D modeling. Now these steps are very much important, uh, and there are different software on each step which you can use to deal with 3D graphics. The first one is 3D modeling. The 3D modeling is a process of forming a computer model of an object's shape. So, for example, for a simple example, if you want to generate a cube, right? So you have to draw the cube on the computer in a 3D. So that is called 3D modeling, where you are generating a model of an object. So if you want to generate model, then you can generate using two methods. The first is nerved based, where you can use line to generate 3D models, and the other is polygon based, where you can use different polygons to generate 3D object. So three in industry there is a technical job called 3D modeler, which just generate 3D different types of 3D models. Okay, and you can generate 3D models into the expert softwares are 3ds Max or Autodesk Maya. Okay, where you can generate 3D models very easily. The second step in the workflow is layout and animation. Okay, layout, what it consists. Okay, the placement and movement of the objects within a scene. I will explain when we go to the Unity that what is the scene and everything. But just remember, it's a blank page, okay? White page, blank page. Like you already know Photoshop and Paint, so blank white page, and you are putting your 3D object on it, and you are assigning color, different materials on the 3D object, different texture on 3D object. You are placing lights on the 3D object which can create shadow of that 3D object. So that is called layout and animation in simple terms. You can also move your 3D object within a scene. So these things consist in layout and animation. Now the third step is 3D rendering. So this is the most important step in 3D rendering. Rendering consists of the calculation that based on light placement, surface types, and other qualities, and generate a 3D image, the final 3D image. So the first is you model the 3D object. The second one is you lay out and animate the 3D object. And third one is render the 3D object. So after this, all the steps, you finally got your 3D, final 3D object or final 3D video or animation. So yeah, there are also job opportunity in layout and animation because in different 3D studios, like for example, there is a Marvel Studio is there. Their 3D teams consist of different personnel. Some of them are modelers, or some of them are light designers, some of them are material designer, and the last comes renderers. So we generate the final product. Okay, so you can opt for any of this position if in the future, and if you know how to go through any of that steps. Okay, now the operation in 3D computer graphics, this is also same as a 2D, translation, rotation, scaling, all the same. Only one more axis is there, Z axis. You have to handle that. Okay. And 3D graphic softwares. The famous one is Unity, Blender, 3ds Max, Autodesk Maya. There are lots of examples. Okay. So let's move towards introduction to basics of Unity environment. Okay. So finally, we are here for Unity. Okay. So let's get started. The first step of this learning Unity is to download Unity. So you know how to download and install the Unity. Okay, so when you go to Unity website, okay, so there are 4 versions of the 4 different versions is available. So you think what I will choose. So the first one is personal version, the second one is plus version, and the third one is pro version. Okay, and the fourth one is enterprise version, which if you are company, then you can purchase enterprise version. The personal version is free. So if you are student or you want to use Unity by not paying any of the amount to the Unity, then you have to choose personal version. Now, all version of Unity provide you with the same engine features. Okay, so any of the version you download, it will have all the features of Unity. But only catch is this. So if you are using a personal version, the most noticeable difference between personal and plus or pro enterprise version is that the games created with the personal version have to start with a Unity splash screen, whereas any of the paid version allows you to either remove the splash screen or create your own. So basically in personal version you will get Unity logo like a watermark, or when you start the app, Unity logo will always appear, you can't remove it. So that is the case. Otherwise everything is similar in all of these versions. Okay, and the for learning purpose, the personal edition is sufficient. So if you want to download it, you can click on personal version and you can download and install Unity 3D. Okay, now introduction to basics of Unity environment. Okay, let's break down the interface. You have successfully installed Unity. Now we will create our first project and we will see different interfaces and different modules of the Unity. Okay, so when you open the Unity, it will ask for open existing project or a new project. I will click on new project, click on 3D, give the project first project, give the project name first project, and create project. So it will set up your first project by implementing different packages, inbuilt packages, and implementing inbuilt features. So it will take some time. Okay, so if you want to use Unity, you need to have a good computer, like with good RAM or good processor. So otherwise, it will take a load in implementing your project. Like if you want to take a render and it contains very high 3D graphics, then it will take a load. So you need to have a good computer. For learning purpose, the moderate computer moderate configuration is fine. But if you want to generate any 3D games professionally, then good computer is necessary. Okay, so this is the by default interface of Unity engine. Okay, let's see the interface. Now you can see that the interface is a bit overwhelming at first, like a lot of windows are there, different windows are there. Now you don't have to worry, I will explain each of them. The interface, this interface is highly customizable, and this interface can provide you with as much or as little information as you need. You can customize it, the whole interface. Now, if you can see the upper right corner, you see 5 buttons. One, two, three, four, five. Okay. Select the last one on the right, which is called layout button. If you open it, it is a drop down, and you can see 2 by 3, 4 split, default, tall, wide. There are different layout. Okay. Please select 2 by 3. So it will change your Unity environment, like Unity interface. So first, you can change the whole Unity interface by selecting the layout on top right corner, layout drop down. You can save your layout for the future use, and I will choose again the default layout. So this is more organized layout. So we will go through this layout. Okay. So now we'll see the modules. The first module is a scene view. This view is in the center of your Unity interface, and here you can see the scene. Okay, the scene view is where you construct your game. Okay, so this is your playground. You can play in the scene view. It is where you put all models, camera, and other pieces like lights that make up your game. So you know the Adobe Photoshop has a white page in the center where you can draw or where you can edit the image. Similarly, in Unity, we have a scene view. It's a 3D scene view where you can put your 3D objects and you can play with it. And you can and you can create a great application or a very fun game. Okay. As you test your game in Unity, the scene view will update itself. So when you run your game, you can see the models or game objects in the scene view will update itself with the current game state. You can even add new elements on the fly to the scene. Like uh, this is a just empty scene view, and if I click on this play button, so it will run this game. This is nothing. No 3D objects are there. But when you click on the play button, it will run your game. Thus, as the in the game view, this is the second view, which is called game view. The game view represents the player's perspective of game. So this is your development playground, and this is your execution playground. Like when the game is executed or when game is played on the mobile device or on the desktop device, how it will look. So you can develop your game here, and you can see or you can test the game here. Okay. Okay, the game view has an aspect ratio selector. So if you check on the top left in the game view, you will see the free aspect drop down where you can select different aspect ratio for testing of your game. Like if you want to test your game on your mobile, like then you have to choose WXGA. So it will set your aspect ratio as your mobile's resolution. Or if you are desktop device which is with the full HD monitor, then you can click on full HD and test your game. So it is for the testing in a different aspect ratios of your devices. Okay, so this allows you to make sure that the game looks good on all aspect ratios and resolutions. So you don't have to have all the devices. Like for example, if you are creating with your mobile game, so it's not physically possible to test it on all the mobile devices with different sizes, with the different screen sizes, right? So you can test by selecting different resolution in the Unity. You select the resolution of your mobile device screen, and you can test your application or game on it. Okay, you can also add a custom aspect ratio. So if the aspect ratio of your device is not here, then you can also add a custom aspect ratio by clicking on the plus button. You can label it and you can give resolution. Click on OK. It will add the custom aspect ratio for you. Okay. So now third view is hierarchy window. The hierarchy window, this is the hierarchy window on the left side. So the hierarchy window contains a list of all the current game objects used in your game. Okay. So here you can see that this is a by default scene, and there is a two object. One is main camera and the second one is directional light. Right now, two objects are added into the hierarchy. Now I am introducing one more term. The objects are used in the Unity is called game object. So any of the object like main camera or a directional light, or you can put any other 3D object, are all called game object. Okay. So from now on we will use the term game object. Okay. Basically game objects are empty containers that you customize by adding components, and components permit game objects to project geometry. or emit light or act as a camera or even create a complex behavior via script. Okay, so if I want to create a game object, then I will right click it and create empty. So, and you can see the name by default will come game object. So this is an empty game object. Here I will move the directional light. So you can see this. This is empty game object here. Right now there is no component added into the game object. Now you can add. This is also the empty game object, but you have added the component camera into it, so it is now become a camera. So in our this empty game object, we can add camera. So this become also camera. So now you can see there are two cameras. So basically, game object is just an empty container in which you can put or add components, different components. Okay, the light is also the same. It is also a game object, and we have added light component in the empty game object container. Okay, game object can also act like a folder containing other game objects. So here is parent child relationship. You can also create your game object in add child game object into it. So for example, if I creating one game object, and if I move main camera into it, then you can see that the main camera game object is became the child of game object. So here is parent child relationship. Okay, so this function, this feature can be used to organize your scene. Like if there are hundreds of game object in your scene, then you can organize by making a child of any other game object. Like you can divide your game objects by category. You can create each game object by category or feature, and you put all of the game objects under it. Like you can organize the things, so it will look much better, and it will be easier to find any of the game object. Now, a scene typically represent a single level of your game. Although you can put your entire game inside one scene. Any game objects actively used in your game in the current scene will appear in the hierarchy view. Okay. So, for example, if you want to add your game object, any of the game objects dynamically in your scene, then you can also do that by doing some scripting. But in the when it will show in the hierarchy window, when any of the game object is put in a scene, if my script is ran, and my script what it does, put a simple 3D cube in the scene, then when the simple cube appears on the scene, it will show you here also in a hierarchy window. Okay, every new scene starts with a main camera and a directional light. So these two game objects are the default one. When you create a new scene, even if you create a new scene, then by default, both of those game objects will come with default scene. And mind you, you don't have to keep them. You can remove them and add your own game objects or own camera or own lights. It's just a by default one. Okay. As your scene grows with a lot of game objects, the search bar will prove to be very valuable. For example, if you have hundreds of thousands of game objects, you can use this search bar here to find a particular game object. For example, if I want to find the main camera, I will write main camera. So it will only show you the main camera game object. Okay, so use it wisely. If you have very numerous game object, then you can use search bar. Okay. Now let's move towards the project window. The project window contains all assets used by your game. Now, where is the project window? It is on the bottom of your UI. This is the project window. Okay. So it is basically a directory structure, actual directory structure of your project. If you say create your project on your storage device, hard disk, it will create different files for the Unity project. So different files which are created or you add in your Unity project, it will show you here. So right now there is only one folder, scenes, and its sample scene is there, which came by default. So this is your project window. You can also drag them from the project window to the scene view. If you drag files from your computer into the project window, Unity will automatically import those as assets. So you can add your file into the project window from by dragging from another folder in the computer, and you can use that file you have imported into the hierarchy window by dragging them from project window to hierarchy window. Okay. Using the project window, Unity organizes the assets in the project window the same as the OS file system does. You may be tempted to make changes directly in the file system instead of in the project window, but remember this. This is a mistake that will break your assets. So you have to manage your file from project window only. If you want to remove file or add file, don't do it from the uh, explore window or file system from the directly from the computer. Okay, use the project window. Otherwise, it will break your project. Okay. So that was the project window. The fifth one is inspector window. Now the inspector window is on the right side of your UI. The inspector window lets you configure any game object. When you select a game object in the hierarchy, the inspector window will list all the game objects components and their properties. So if you selected a main camera here, you will see different components which are already added into your main camera game object, and it will show properties of your different components. Like for example, the first property is transform. First component is transform. So basically what transform does, transform is a combination of location, position, rotation and scale. So you can give three coordinates value of any of the property, position, rotation or scale. So if I change the property, please see the screen. I have selected the main camera, and if I change the property of a position for to y coordinates to 5, it will go up. Okay. If I change it back to 0, it will come down. So you can change all the properties of all the components which are currently in game object from here. Okay. So this is the very easy one. And if you want to add a new component, then you can click on the add component button, and it will give you the list of all the components available to add in your game object. So you have it is categorized. It is categorized wise. So you have to select the category, and you can select the component, and then it will add the component in your game object. Okay. The sixth one is toolbar. Now the toolbar is on top of your top left of your Unity UI here. This is the toolbar. We will go through some of the components of the toolbar now. The toolbar is used to manipulate the various game objects in the scene view. Okay, you will use the following tools as you develop your game. So these are the basic tools. So let's get familiar with them by trying them in your empty project. Okay. Okay, so let's first add a simple cube to the scene. Okay, so how to add a simple cube to the scene? Okay, so Unity gives you the basic 3D models which are already available in the Unity interface, where you can click on that 3D object. It will directly edit into your project. You don't have to create them. So for that, you have to go to the game object menu, go to 3D object, and select cube. So you can see that it will by default added into your scene. So this is the 3D cube, and you can also see in the hierarchy window. Okay. Now there are other ways to add it also, which we will see in the future, where we develop a small game from where you can add the different by default 3D object. This is the one way. Go to the game object and select 3D object, and you can see various default objects are there: sphere, capsule, cylinder, plane, quad. These are the default 3D objects. Okay. Okay, the first tool is handy tool, which is actually very handy. And it has a bunch of features built right in. Okay, so if you select the small hand icon, okay, and drag your mouse over the scene view to pan the entire screen. So you click on your scene view, hold your mouse left icon, and you can pan the window. Okay, and if you do right click and drag your mouse, it will rotate your camera. Okay, so if you click on the left, it will pan the window, and if you hold the right click and move your mouse, it will rotate the camera around your current position. Okay. Now, next feature is, now hold down Control and Alter both together. You will change your hand icon will change to the magnifier. Okay. So this functionality is used to zoom in, zoom out. So now by holding Command, Control and Option, and by moving mouse, you can zoom in, zoom out. Okay, and also you can use your scroll button on your mouse to zoom in, zoom out. Okay, now the next one is translate tool. This four arrow. So when you click on it, it lets you select and position a game object into the scene. Now you can notice that when you select a game object while the translate tool is active, there are three colored arrows drawing from its center. So you can see that three arrows are there: blue, red, and green. Each arrow indicates the three-dimensional axis of the object. The x-axis is a red arrow, y-axis is a green arrow, and the blue axis is a z-axis. Blue arrow is a z-axis. Now, there is a name or term for this three axis, and the term is gizmo. This gizmo indicates direction of each axis. As we will learn more in the future, you will know how to use gizmo correctly. Okay. There are many ways to move your game object with the translate tool. You can select one of the arrows which will turn into yellow when selected. So go over the one of the arrow and click on left click, do your mouse left click, and it will turn the arrow into yellow color. Now move your mouse by holding the left button. So right now I have selected the Z axis and I'm moving the mouse, so it is translating the 3D object on Z axis only. If I pick the red arrow of the gizmo, it will move my 3D object into the X axis. Okay. So what if you want to move your object in the two of the axis with respect to two of the axis? Then you can see there is a small squares in the center. So if you select the red square, it will move the object into y axis and z axis. You can see both the axes are turning into the yellow color. Then you can select here, so it will move your object into the x and y axis. So translate is a very helpful tool. You will have to use more frequently when you create your game or a project. Okay. Now the third one is rotate tool. Okay. So the rotate tool lets you rotate the object. It's very simple. You will notice that three spherical colored lines when you select the object to rotate. So if there are three spherical colored lines, one is green, one is red, and one is blue. It's the same. It is called rotation gizmo. In translation gizmo, there were three arrows. In rotation gizmo, there are three spherical lines, circles. Okay. Now, if you choose one of this line and move your mouse, it will rotate your object. Okay? So that is rotation of your game object. Now, the fourth one is the scale tool. The scale tool lets you scale a game object either along a single axis or proportionally on all axes. So here you can see the scaling gizmo is look like this. So if you want to scale the game object with your x-axis, then you select it, you move your mouse, it will scale up, scale down, scale up, scale down. Okay. Now the important catch is, what if you want to scale up your object or scale down your object on all of these three axes? Then you go to the center, select the cube in the center, and it will scale up, scale down on all three axes equally. Okay. So that was the scale tool. Okay. So now we'll move towards the play button. I've already shown you the play button, there are three buttons in the center of your UI, top center. The first one is play button. Okay. The play buttons lets you start and stop your game. The first button which lets you start and stop your game. A few things happen when you click on the play button. First, your game will start, and the play buttons, the button set will also turn blue, indicating the game is in motion. So you can see that the button is converted in blue color. So you can identify whether the game is right now playing or not. Okay. Remember, now this is the most important thing. Any changes you make on the fly while the game is playing will be lost once you stop the game. Okay, I will explain this. Okay, right now I will stop the game and select the cube. Okay, I will rotate the cube 90-degree with respect to y. Okay, I will change rotation properties by 90, doing 90 on the y-axis. Okay, 90 will not 45. Let's do 45. Okay, 45 is also good. Yeah, 30 is fine. Okay, so you have rotate your game object by 30 degree, right? So right now it will stay 30 degree, but this change if you do while your game is running, then that change will be lost when game is stopped. So I will change it back to the 0 again. I will run the game. Okay. Okay, the camera has been moved. I'll move back the camera so you can see it on the screen. Okay, now it is visible. So, okay, now the game is running. Now, if I select the cube and change rotation to 30, so you can see that the cube rotated. Now, I have done changes while the game is in motion. Okay, so when I stop the game, notice here the y coordinate y rotation of the y degree rotation of, right. When I stop the game, it will turn back to 0. So remember this: don't change your properties. If you want to make it permanent, then don't change your properties while the game is in motion. Those changes will be lost when you stop the game. Okay, so this is the most important, and beginner often does this mistake. Okay, so for example, if game is in motion and you tons of changes in your property, right, and you want that those changes to be permanent, but you have done it while the game is in motion, so all will be loose, all will be lost when you stop the game. Okay, so remember this. Okay, the next is pause button. The pause button, the name itself suggests, will pauses the game and lets you make modification to the game. Okay, so we have seen that the properties are lost when we stop the game if we have made changes while the game is in motion. So there, pause button came to the rescue. So if you playing your game and you want to do important changes in the property, okay, then you just have to pause the application. You do the changes in your property windows, and you can again play. You can unpause the game. It will be still there. Okay. Okay. The next is step button. This lets you step through your game one frame at a time. Now, one more important term I'm introducing right now. The term is called frame rate. Okay. Many of you know that the normal video plays at a 24 frames per second. So in 1 second, you will see 24 frames. So now now many of you have played games, right? So it many games show you the frame rates like 60 frame rates, 70 frame rates. If there are more frame rates like 120 frame rates per second, you can see the smooth animation. If there are less frame rates, then it will a bit the animation looks not good, like it will be edgy, right? So that is called frame rate, displaying of frames in 1 second, which is called frame rate. Okay, so Unity is used to build a game, so it also supports frame rate. Okay, so if you want to go step by step in a frame rate by clicking on step button, it will render each frame when you click on the step button. Like if the frame rate is 24, then you have to click step button for 24 times to complete 24 all of the 24 frames. We will show I will show you how to use it when we build a small computer game. Okay. Okay. uh, okay, now next important thing is build UI. Yeah, so the build UI, if you go to the file menu, go to the build settings. The build settings window is opened. Now you can see it here, the various platforms are listed. Now Unity is a cross platform engine where you have to develop your game, or you have to program your game, or you have to code your game only one time. You can take different build on different platform. For example, the game which we are creating today, you can run that game, or you can take a build of your game on a different platform. Like you can run it on your iPhone also, and you can run it on your Android also. So you are building iPhone app and Android app by doing just code one time. If you use Android Studio, then your application will be built for the Android only. If you use Xcode, then your application will be made for iOS only, right? But you can make application cross-platform from here by doing the code only for one time. So you just have to select the platform and click on build and run, and it will run your application on that platform. Right now, the current platform is selected PC, Mac, and Linux standalone. Okay, so right now we can take a build for a PC or Mac OS or a Linux. You can see that you can change your target platform from here. But you also need to install packages or platform installation from Unity website. So if you want to create a build for your PS5 or PlayStation 4, you just have to add a platform module, then you can take a build. Okay. Okay. So we are done through Unity UI. Uh, let's create our first Hello World application. Okay. Okay, I will delete the queue. Okay. Okay. In other programming language, when you learn those, you write a print. For example, if you are doing a C programming language, you write a printf hello world, right? So in this Unity, our first application, we will literally create the world. Okay. So let's create a sphere first. Go to the game object, create 3D object, and select sphere. Okay. Okay, so the sphere has come. Now we want to make it as a earth. So we will overlap one image of earth's map on this sphere. Now I am introducing one more term which is called materials. If you want to apply images or texture onto the 3D model in simpler terms, that is called material. So we will create materials with a earth image. Okay. So first we will import the earth image from the computer. I already downloaded this earth image. Okay. So this is the flat 2D image of earth. So I will import that image by dragging and dropping into the project window. So you can see that image is important. Okay, so now you select that image and click on apply in inspector window. So you have to select. Okay, now you just create your material, go to the create, or you can also create from here. Yes, you have to right click on project window and go to the create and select material. So it will create one file. You have to name it earth material. Okay, so now the material file is created. Okay, so now you have to select your imported image and you have to put it in your material. Okay, so when you click on material file, you will see the shader, different type of shaders in the uh, uh, shader drop down. So you have to select. You have to select. You have to go to the mobile and go to the bump diffuse and select the bump diffuse. It will show you two boxes here. Go to one of the boxes, and when you click it, it will show you your image file. Select that image file. Now you can see that your material has the earth image. Now you can drag and drop your material over to the sphere directly in the scene view. So the material has been applied. When you rotate your game object by selecting rotating tool, you can see that the whole earth image is applied over the sphere. Okay, so this is our first hello world project. This is the simple one. Okay, so now when we play it, you can see the earth is there, sphere is there, and the material has been applied. Okay, now we will add one more thing. It is not rotating. Now, what's the use of earth if it is not rotating, right? So we will rotate the earth. We will introduce a scripting now. Okay, so to create a script, as I've already told you, the Unity engine uses the C sharp as a scripting language. So create a script. You have to right click on the project window, go to the create and go to C sharp script. Okay, so new script will be created. Now name it rotate. Now double click on it. So it will open the script editor. Now, in latest versions of Unity, the default script editor is Visual Studio. But if you are using other script editor, then also you can use it for C sharp scripting for the Unity. I am using Visual Studio Code for the scripting, but you can also use text edit or Visual Studio for the scripting. Okay. Now, uh, when you create your script file, you will see by default this script appears. Okay, so you can see that there are different packages which are imported by defaultly in default script. One is collection, one is generic, and one is Unity engine. So these are the default script you need to default packages you need to import into your script. Okay, For example, if you are developing program in C, then you have to import stdio.h, right? So it's the same like that. Okay, and C sharp is a object oriented language, so the default class is also created, rotated, and two default function are there. One is start and one is update. Now when this script is called, start function is called automatically before the first frame update. So when the script is loaded and the first frame comes, the start is called by default. Okay, so whatever you want to load before the script start, you load it into your start function. The next is update function. Update is called once per frame. So for example, if the frame rate is 24 frames per second, this update function will call 24 times in 1 second. So whatever you want to manipulate every frame, you put it in your update function. So frame rate can increase according to the hardware or a memory. Like for example, if you are playing your game on your mobile and right now the frame rate is 70 FPS, and if any other application is working in the background, then your hardware has to reduce the frame rate in your game. So it will reduce it to 50 frame rates. So now the update function is calling for 50 times per second. Before it was calling for 70 times per second. So it will be called once per once per frame, and 24 frames per, if there is 24 frames per second, then it will be called for 24 times per second. Okay, so these are the two by default function. So we will write the simple code now. We want to rotate the sphere, so we will write transform dot rotate, and we have to give the xyz coordinate for rotation. As it is a 3D, we need to give 3 coordinates. If it is 2D, then we have to give only 3 only 2 coordinates. So we want to rotate it by with respect to the y-axis. So other axis will be the 0. Now the y-axis is equal to 5f, and the z-axis will be the 0 again. Okay, and we have to add a uh, space reference. Now the space reference is little bit advanced. For now you add space dot self by default. So we are rotating our sphere at the speed of 5 with respect to y-axis. X and z axis will be the 0 because we are not applying any rotation with respect to those x and z axis. So that's why they are 0, and only y-axis is 5. And here we have given the value as a float. So I have written a f behind the 5. So 5. So we can know that 5 is a float value. Okay. So let's see whether it is working or not. So let's move to the Unity editor. So it will compile your script. Transform does not exist in current context. Okay. So right now the method which we are using, we need to import it first. Then only we can use it. Okay. So we will complete this after we learn more aspects of scripting, so you can understand what is a space, what packages we need to import to run this transform. Okay, so we will put hold on this right now, and we will move forward with another aspects of scripting. Okay. Okay. During this seminar, we will create a small game in Unity. So, and we will do scripting also. So we can cover all the aspects of the Unity and scripting. basic aspects, because game development is not that easy. Like if you want to also create simple game, then it is very complex to create the simple game also. Okay. Okay, so we will minimize this project. We will do after some explanation of things. We'll complete it. Okay, so we will save it for now, and we will create another object, game. Okay, okay, so we will create this game. We will create a small game of shooting the enemy, where one sphere is there and it shoot the projectile or bullets to the enemies. Enemies will spawn randomly in the arena and you have to shoot it. If your enemy touches you, then you are dead. Okay, you have to shoot your enemy. Okay, so first we need to create the arena. So you see that there is a square arena is there. So first you have to create it. Okay, so basically what that arena is, one is floor and other four sides are the walls. Okay, so we will create the arena first. Okay, I will create the first game object, empty, and name it arena. Okay, okay, now I want to add a floor for this arena. Okay, so I will create 3D object which is called plane. So the floor has been created. Okay, now I want to change the color of the floor. So I will add the materials to it. So first I will create the folder in project window called materials. All of my materials will be stored under the materials folder. So I will go into the materials folder and create one material, naming floor. Okay, and I will change and give the color to the material is 7C, 7C, 7C. Basically, it's a gray. Okay. Now I will assign that material to the object. So I will drag and drop that material and assign it to the plane. So you can see the color has been changed. Okay. So now it is a gray material over the plane. Now we will create the walls of the arena. So again, uh, you select the arena, go to the game object. Oops. Game object, go to 3D object and select cube. Okay. You translate the cube little bit and translate it to the edge of the plane. Okay. So now it should look like a wall. It should be look like a wall. So we will scale this cube by selecting the scale tool and scaling with respect to z axis. We will compress it little bit. Okay. Again, we translate it to the edge of the plane. Okay. So now I will change the view. You can see this little gizmo on the top right view of the scene. So it will show you the different axes. So if you select any of the axis, the scene will change its view. So right now I've selected the y-axis. So I am seeing the scene from top of that scene. So I'm looking down right now. So it will help me to adjust my wall properly. Okay. Okay. So now I will create other three walls. So I will. Okay. And one more thing, you need to move your this wall under the arena game object. So it will be the child of arena game object. So now, right now we have created one wall. Now we want to create other three walls. Now the plane is square right now. Okay. So the length of the wall, four walls, all will be the same. So we can use existing created wall here. So right click on the cube, duplicate it. So it will create the duplicate game object. And if you translate it, so it will create another wall. Now, one more time duplicate, but we need to align like horizontally. So select that game object and go to the rotation and do 90-degree rotation with respect to y-axis. And again duplicate the cube. Okay. So I think the arena is ready. It's a little bit small. We can grow the size. I will quickly adjust the walls. Okay. I think it's enough now. Okay. Okay. Great. Okay. Now our arena is ready. We will move forward. Okay. So right now, if you click on your main camera, or you can go to the game view, and you can see that it is looking right now like this. So our arena is looking like this. So we will adjust that to look it in a better way. So we will move camera up. Now you can see the game view. It's a little bit off. So we will rotate the camera downwards. So select the rotate tool. Yes. Now it's looking a little bit better. So, okay. So we will keep it like this for now. Okay. So again, back to the scene view. Okay. So every game needs a hero, right? So your first task is to create a game object to represent the player in the scene. So in the game, what do you play? You play the player in your game. So we are going to create one player in the scene. So right click in your hierarchy window, create empty game object and name it player. Okay. So our player will be the sphere. So let's create the sphere first. Okay. And its location is good, and we will make it uh, a child of a player game object. Okay. So you can see the sphere is on the plane, is in our arena. If you go to the game view, you will be look like this. Okay, you are good to go. Okay. Okay, now we have to add a few of the things. Okay, we need to add different components now to our game, our player. The first one is a rigid body. Now we are going to shoot towards the enemy. Enemy will come towards you, and it will collide with you. So it will be all physics. You need to have acceleration. You need to have a speed. So basically, for the collision, you need to add rigid body component into your player. So select your player, go to add component, and create rigid body. Find rigid body component and select it. So you can see that the rigid body component is added. Okay. Okay. Another already added component is sphere collider. Now, what is collider? A collider in the shape of a cube or sphere, like different collider is that sphere collider, box collider, like that. Box collider comes in a shape of a cube. Sphere collider comes in the shape of a sphere. So what it does, it will it will be used to detect the collision. If there are two objects are there, 3D objects for two sphere are there, so both of them are having sphere collider, and in the game both of them are hitting one another, colliding with another. Then collider is used to detect the collision in the script. So right now sphere collider is there, rigid body is there. Okay. And another one is mesh filter is there. Okay. Okay. So, okay, let's make sphere independent than the player, and we will delete the player, and we will name this player only to avoid some complexity. Okay. So we have created a sphere, we named as a player, then we added rigid body, sphere collider, and mesh filter and mesh renderer were always already there as a default component. Okay. So now adjust the rigid body value like this. I am telling you, set drag to 1. We will change drag to 1. Angular drag to 0. And check the Y checkbox next to freeze position in the constraint. If you click on the arrow beside constraint, it will open this thing. And freeze, you need to click on Y axis on freeze position. You need to check that. Okay. So freeze position means it will stick your game object to uh, x and z axis. It will freeze the position of y axis. So you can see that this is the x-axis, this is the z-axis, and this is the y-axis vertical. So it will freeze your y-axis. So your object cannot move up and down. Okay, it will only move into the xz plane, horizontally and vertically. Okay, on x and z plane basically. Okay, so let's move this our player. So for that, I will create one another folder which is called scripts folder. We will keep our scripts in this folder. So I will go into that folder and create one script. I will name it player moment. So this script will be used for our the movement of our player. So again, it will come like this as a by default. Okay. Now, as I am using the folder, using the folders like this makes it easy to organize everything. Because when you create the large project, there will be a lot of files into the project. So you have to divide your files among the different folders. So it will be well organized. It will look well organized, and other developers can find your files very easily. Like you will work in your team in the future. You only you are not going to work on a single project. Different your team member will work on single project. So you need to organize the files in a good manner so others can find it. So use folder wisely so you can organize your files. Okay. Okay, so in our script, okay, yes, we will create two variables first. First will be the acceleration. So I will make it public, and the data type will be the float acceleration, and the other will be max speed. Now these I have made them public, which means that these variables will be visible in the inspector window and can be changed without having to go back and forth between scripts and the editor. Now this is the very important feature. If you make your variable public, then for this script player moment, and you assign that script to our player, like drag and drop on the player. In the inspector window, you can see that acceleration and max speed. So you can change those values from here only. For example, I will change the acceleration value to 5 and max speed value to something else. So you don't have to go to the script and change it like this again and again, equal to 5 or equal to like this. You can directly from Unity editor. Right now I will make it empty. Okay. Now, what we will use these variables for? The first one is acceleration. Now, acceleration variable will be for how much the player speed increases over the time. Okay, so it will describe the acceleration of our player, and the other variable is max speed. And the max speed will describe the maximum speed which our player can attain. Okay, so max speed will be the speed limit for our player. Now we will create two more variables. I will make them private as I don't want to use them for from the inspector window. So private rigid body private key code input keys. Okay. I will also add another variable private vector 3 directions for keys. Okay. As I've told you, private variables can't be set through the inspector. It's for developers' responsibility to initialize them at the appropriate time. Okay. Okay. Now let's see what I have created these three variables for. Okay. Rigid body will hold a reference to the rigid body component that's attached to the player game object. We have already attached a rigid body component to the player object, game object. So it will handle, this variable will handle the rigid body component. Okay. Input keys is an array of key codes that will be used to detect input for player. We will use W, A, S and D keys to move the player into the arena. So that input keys array variable will hold the key values for the detection of input. Like if I press W key or if I press A key on the keyboard or S key or D key, right? And direction for the keys variable will hold an array of vector 3 variables which will hold directional data. Directional. Now we are handling 3D object, so there will be three coordinate system, right? X, Y, and Z. So to give any direction to 3D object, we need to create a vector 3 data type variable with vector 3 data type. What is vector 3? Vector 3 contains 3 axis value. That's it. X vector value, Y vector value, Z vector value. Okay. So let's implement the code. We'll write, we'll start from the start function. We will initialize the variable which we have already declared. We'll first declare input keys equal to new key code. We'll create the array key code W, key code A, key code S, and key code dot D. So we are going to detect 4 keys: W key, A key, S key, and D key. Okay. So we are creating array of the input keys first. Okay. We have initialized the input keys variable. Let's initialize directions for keys. Direction for keys equal to new vector 3. It's also array vector 3 forward, which will hold coordinate for the x-axis. Vector 3 dot left vector 3 dot back and vector 3 dot right. Forward, left, back, and right. Okay. And we are initializing the rigid body. We will now we have used get component. Now what get component do? It will give reference of the component already added into your variable. So I will use get component method. And what is the data type? Rigid body. Okay. So it will assign this get component, this added get component to the rigid body variable. Okay. Okay. So this piece of code links the corresponding direction for each key. For example, pressing W moves object forward. So W and forward. And if I press the A key, then it should move the object on the left. If I press key S, then it will move the object in the back direction. And if I press key D, it will move the object into the right direction. Okay. So let's create the code up for the movement, actual movement. Okay. So now we will use another function, which is also the inbuilt function, which is called fixed update. Okay. So let's see why we are not using update function. Instead of that, we are using fixed update function. There is an issue with update function. As I told you, update function depends on the frame rate of the game, and frame rate changes if the some memory is occupying, if the processor is busy, then frame rate goes down. If the resources are free, frame rate goes up. If network is down, then frame rate goes down. Like, it depends on the many parameters, other parameter, hardware parameters, software parameters. Okay, but we want to move our player at the constant speed. So now another function is that fixed update. Now, fixed update is independent of the frame rate. It doesn't depend on the frame rate. Fixed update should be used only when working with rigid bodies. Instead of running as fast as possible, this method will be fired at constant interval. Interval is fixed. It doesn't depend on frame rate. Okay. So we will create the loop to see if any of the input keys are pressed or not. Okay. So we'll create the loop now. We'll create the for loop. We'll create the control variable I less than input keys dot length I plus plus. Okay. Where key equal to input keys I. Now this local key variable will hold which current input key is we are looping through. Okay. Now we'll enter input dot get key. Okay, so this is the inbuilt function input dot get key, and we are giving the parameter as a local variable from key code input keys array. So Okay, and this might cause things to happen too fast on powerful machines, on too slow on weaker ones, which can cause undesired behavior. The general rule is when you perform an action every fixed frame, you need to multiply by time.delta time. Time.delta time is nothing but the difference of time between each frame. So it's for example, the first frame is coming on the first second, and the second frame is coming on the second. The time.delta time is 1 second. The difference of time between two frames is 1 second. So when you are using fixed update, you need to, and you are using rigid body, you have to, if you want a movement, then you need to multiply it with time.delta time always. Okay. Okay. So we are done with the movement calculation. Let's add another function, void move player, and it will accept the parameter movement. So in fixed update function, we have calculate the movement, and we will assign the movement to our player now. If rigid body dot velocity dot magnitude multiply by acceleration greater than max speed is okay. Here what we are checking, if the current speed of the rigid body multiplied by acceleration is greater than max speed. We have given the max speed variable, so it is for speed limit. We don't want to accelerate our player to infinite speed, so we have to give some limit. So if our player speed becomes greater than our speed limit, then we are decreasing our speed to get back to the limit. Add force movement multiply by -1. So we are reducing the speed if it increases greater than our speed limit. Add force is also the inbuilt function. So we are introducing force in opposite direction. So I have multiplied by -1. Forward direction is 1, and if we want to movement in, it's like you are riding a vehicle. It's you are moving forward, and when you apply the brake, the opposite force will apply, so your vehicle will be stopped. So we are applying opposite force, so I am multiplying movement with respect to -1, so it is applying force in the opposite direction to stop the to reduce the speed of the object player, because it increased its speed greater than our speed limit. Otherwise, if the speed is in the limit, we will increase the speed. Add force movement. Okay. So we have also done code to actual move the player. Okay. Now we want to call this function into this fixed update function, move player, and we will pass argument movement to it. It looks perfect now. The player movement script looks perfect now. Let's review one more time. Okay, let's save the script and return to the Unity editor. And in the project window, drag the player movement script onto the player inside the hierarchy. I have assigned the script to the player. I will remove it. Okay. Okay, let's set the acceleration and max speed. Let's set acceleration at 6 to 5 and the max speed will be 4375. This is just a random value. You just have to try and test the speed, acceleration, and max speed, and you can enter your values also. Okay. Okay. So uh, let's take a break for 10 minutes and we'll come back for the later learning. Okay. So let's just take a break of 10 minutes.
Okay, students, it's a break for 10 minutes. Don't leave this meeting, just be joined and you can enjoy the 10-minute break.
Okay, we can resume now. Okay, so let's get back a fast recap first. We have created the player movement script. Okay, so we have created first two variable, acceleration and max speed. Acceleration is for the acceleration of the player, and max speed will be the speed limit of for the player. Then we have created rigid body, input keys and direction for keys. Rigid body is for handling the physics of the player, and the input keys and direction for keys are for detecting the which key is pressed on the keyboard. Then we have initialized the variables in the start function. Then we have created the key detection code in the fix update function, and then we have calculated the moment based on the key pressed, and we have assigned that moment by creating move player function to the our player's rigid body. And we have also put one check that our speed of our player should not increase than our max speed. So we have assigned our script to the player, and we have given the acceleration and max speed values. Okay, so let's test the script. Okay, you have to click on the play button. Okay, so you have to use W, A, and S and D key. Okay, so I will press W key. Oh, you can move. You can see that the our player is moving. You can control your player using this key. Okay. Okay, that's pretty good result for on lines of code. Uh, and there is also one issue is there. The player can quickly move out of sight right now. Oh, okay, so the whole arena is not visible, which makes a little bit difficult to fight the bad guys when we create the bad guys. So we need to move the camera according to the player's movement. So let's create the script for that. Let's create the camera script. So in script folder, we will create another script called camera rig. And attach it to the main camera. Okay, it is attached. Now we will create the variables for the same. Okay, so now we want to move camera with the our players. So we will need to create the speed of the camera also. So we will create one variable public float move speed. Okay, and we want to focus on the player. So we will create one game object called target. So we are targeting the player, our player, to focus. So these two public variables are created. Then we will create one direction or transform for the camera rig transform. Okay. So now, as I've explained, move speed is the speed with which a camera will follow the target, which can be any game object inside the scene. For our project, we have the players as a target. Okay. So now we will initialize variable rig transform is equal to this dot transform dot parent. Okay. Okay. Now this code gets a reference to the parent camera objects transform in the scene hierarchy. So this dot transform dot parent, what it does, it gets the camera objects transform means the three values, location positions, rotation and scale values into the scene hierarchy. Every object in a scene has a transform. So our player has a transform, camera has a transform, and transform is nothing but the position, rotation and scale of an object. Okay. So in the same script, we will add new method void fixed update. This is also the inbuilt method which we can override. Target equal to null. If we can't find a target, then return. Else target means our player. So our player is not found, then return. And if found, then rig transform means we are transforming the camera position equal to vector3 dot lerp. I will explain the lerp. It is also the inbuilt function. Rig transform dot position target dot transform dot position time dot delta time multiply by move speed. Okay. Okay, the camera movement code is a bit simpler than the one in player movement code. This is because you don't need a rigid body. Simply interpolating between the position of the rig transform and the target is enough. Okay, so now the lerp. Uh, what does lerp do? It takes 2 points in the space and a float in the range of 0 and 1, which describe a point along the two endpoints. The left endpoint is 0 and the right endpoint is 1, and passing in 0.5 to lerp would return a point exactly between both endpoints. So we have given here the transform of the target. The starting point is current camera position, rig transform dot position, and the destination place is the player target position. I mean player position. So what does lerp do? It will calculate the points between uh, camera position and the target position, and it will move. It will find the points and move the camera at a speed of target delta time, time dot delta time multiplied by move speed. So it just move your camera towards the target because we are given the target's coordinates at the destination. This is the source position. This is the destination position, and this is the movement speed. So three parameters you have to give in lerp. Okay, this moves the rig transform closer to the target position with a little bit of easing. In short, the camera will follow the player. Okay, now return to the Unity. Okay. We'll select the main camera and we'll set the move speed to 8. and we want to assign our player to the target. Because our player is the target, we will drag and drop our player into the target. Okay. Okay, so let's see whether it is running or not. Oh, okay, the game was running, so our changes will be gone. So let's assign the camera. Player. Okay. Okay. It's giving some error. Okay. We'll create camera rig and put main camera into camera rig. Yes. So you can see that now the camera is also moving with the player. So now we can see each and every part of the arena. Wherever our player moves, we can see that part. Okay. So basically our player and the arena is ready. Uh, let's create some enemies. A shooter game without enemies uh, would be very easy. So let's create some enemies. Okay. So let's stop the game and we will create cube as an enemy. We will name it enemy and we will give coordinates, position coordinates 2.5 and 4. So here is our enemy now. Okay. So, but we have to move the enemy, right? Otherwise, it will be set static. So let's create a script for movement of our enemy. Let's create C# script. We will name it enemy and we will assign it to the enemy game object. Okay, the script has been assigned and let's get to writing the script. Okay, so first one thing we forgot that we need to add rigid body component. So we will add rigid body component and we will checkbox Y in the freeze position to avoid enemy movement in the vertical plane. Okay. Okay, so we'll go to the script. Okay, we will declare the variable public dot move speed. Okay. Now another variable we are introducing health. Public int health. Health is a variable which will detect the how what is the enemy's health. Like if you shoot your enemy, you have to give 3 health to enemy. Like you have to shoot it for 3 times. So then enemy will die. So you have to, that health of the enemy will be stored in the health variable. Public int damage. It will store how much damage has been done to the enemy by your bullets or projectiles. So, and another one is public transform, target transform. Okay. So target transform, here it is same as a camera. So the enemy will follow you. Right now camera is also following the player. So now enemy will also catch you. So it will follow you behind. So we have created move speed and target transform here also. Okay. So let's move to the Unity editor again. And let's create a script, new script. We will name it as a player. And this script will be there to detect or react to collisions and keep track of the player's health. We have created the variables to track the enemy health, and now we will create the variable to track the player's health. Okay, so let's go to that script. Let's add health variable public int health equal to 3. So we are giving player health is 3. And to handle the collision, to detect the collision, one inbuilt function is there on collision enter, which is inbuilt parameter, by default parameter is collision, and we will create script in it when what happens when the collision occurs. Okay, so we will create one object of enemy called dot collider dot game object dot get component enemy. Okay, if collision happens, then we are getting component of the enemy, and we are now going to create user defined function void collided with enemy. Here we are getting component of enemy. If when collided health of the player is less than equal to 0, then we will write the script of that player is dead. If health moves below 0, then player dies. So we will write that script here. Okay, and on collision enter triggers when two rigid body with colliders touch. The collision argument contains information about such things as contact points and impact velocities. So this will give the contact points and impact velocities of the collision, where on what point both objects are collided and at which velocity they were collided. In this case, we are only interested in enemy component of the colliding object. So you can call collided with enemy and execute at the attack logic, which we will write next. So when the collision occurs, we just have to detect that whether we are collided with enemy or not, because we have a whole arena, right? So we can collide it with the wall also. So we need to detect that whether actually we are collided with enemy. That's why we are getting component here of any enemy, and on collision we will call collided with enemy, and we will pass enemy here. Okay. Now we will switch back to the enemy part. We will create fixed update function. If target transform not equal to null, this we have checked in camera also. If target is not equal to null, then we will move this enemy transform dot position equal to vector 3 dot move towards. This move towards is also inbuilt function. We have to use that. Move towards this dot transform dot position target transform dot position transform position, and it is if fixed update say that why we are going to use delta time as a multiplier with move speed. Okay. Mm. Okay. Now, in the camera movement, we have used the lerp function, and now here we are using move towards function. So now there is a slight difference between move towards instead of lerp, because here enemy should move at the same speed all the time, not easing it is approaches the target, because uh, whenever camera approaches the target, it should slow down. It should not move forward before the target, our player. So but the enemy should move towards our target, our player, at the constant speed, and it should not stop. It should collide with the player. So that's why we have used move towards. The parameter is same. The current position of the enemy is in source. In destination, the position of our player, and the speed same. The function is different, but the implementation is same. We are using same three arguments. Okay. Now we'll move back to the player script. Okay, and here we will add enemy dot attack. Okay, so now attack is also the inbuilt function. Now what it does, it applies damage to the player, and then the enemy destroys itself. So when both collide, it will apply damage to the player, and enemy destroy itself on collision. So this is the attack. So ultimately, the player will take damage and the enemy will self-destruct in this process. Now we'll switch back to Okay. Yes. The code seems fine. Okay. So we will add two couple of function. Public void take damage. Damage. Health is equal to health minus damage. If health less than equal to 0, destroy. Destroy. Okay, so now what we have done, we have created take damage function. On and each take damage, we are reducing the health count. So if the health count goes below 0, we are destroying this player. So if player's health is 0, then we are destroying the player. So destroy is the inbuilt function which will remove the game object from the scene. So we have used that. We are also going to create another function, public void attack, that we have used below. And player player. Okay. Player dot health equal to player dot health minus this dot damage. Destroy this game object. Okay. Okay. We have done one mistake. These two methods should be in enemy.cs, not the player, because we are destroying. Yes. Yes. Okay. This looks good now. Okay. Let's switch back to the Unity editor now. Okay. So we'll set the public variable value of enemy script. We'll set the move speed to 5, health to 2, damage to 1. Okay, and we will assign the target transform to the player, same as a camera. So if you see in the camera, we have assigned the target to the player, and also here target to the player, because camera and enemy both follows player. That's why. Let's try and run the game and see the result now. You can see the enemy is following the player. Let's reduce the speed of the enemy a little bit. To you can see wherever the player goes, your enemy is following him. Okay. Yes. Okay, let's add some more code. Uh, we'll go to player script, and we will add here condition if enemy, then and then only on collision we should fire collided with enemy, because we can collide with the wall, so that's why we are checking here. Okay. So uh, right now our partial game is ready. So what the game is, you have to avoid the enemy from collision, right? So it's a pretty one-sided game right now. Let's arm the player for a combat. Okay. Let's create the bullet this time. Uh, Go to game object and create capsule. Okay. Okay, this is the capsule. We will change the some property. We will give it rotation, so it will look like a bullet. We will also scale down the size 0.075. Okay. Okay. So now it looks like a bullet now. Okay. Okay. Each time the player shoots, it will fire an instant of this projectile. To make this happen, we will need to create a prefab. Now I am again introducing new term prefab. So how to create prefab? If you want to create a game object on a real time, then we will create. We have to use prefab. Now, for now, what we have done, we are dragging object from project window to the hierarchy window, right? Now in this we will do reverse. We will drag a game object from hierarchy to project window and create prefab. So for that I will create one prefab folder. We will store all the prefabs here, and I will drag this capsule. First we will rename it to projectile. Okay, and now drag and drop. So you can see that the prefab, when you select this, you will see that prefab asset has been created. Okay. Okay. Now for shooting script, we need to create one more script. So we'll create a script named projectile. And projectile also moves, so we have to give a speed also and direction, in which direction we are shooting. So we will create variables speed vector3 shoot direction and public int damage. Okay. So for acceleration of the projectile, we will create a fixed update or fixed update function. This dot transform dot translate shoot direction speed. Okay. So here it is simple. We are straightly shooting. We are not following the target. We are just shooting the bullet in that any direction. It doesn't follow any target. Okay. So here that code is simple. Okay. So here we'll write more script. Void fire projectile ray shoot ray. This the shoot direction equal to shoot rate of direction. I will explain this in some time after I've done with the code. Transform dot position equal to shoot rate. I will create another function public void on collision enter collision call enemy call enemy call collider dot get component enemy. This is the same code as we have done in enemy or player. Tech damage. Okay, so here I will explain the code. If a projectile collides with an enemy, it calls take damage function and destroyed itself. In the scene hierarchy, attach the projectile script to the projectile game object first. So we will assign the projectile and we are getting transform. Okay. Transform. Accept date. Translate. We have yes. Okay. We will set the speed to 0.2 and damage to 1. Okay. Now we have created the projectile prefab, so we can remove the projectile from hierarchy window because we are creating the prefab game object from prefab dynamically. Okay. Okay. Now that our prefab can move and apply damage, we are ready to start shooting. Inside the script folder, create a new script named player shooting. So player shooting. And we have to attach that script to the player. Okay. We'll open that script and we'll create some variables. Projectile prefab public layer mask. Okay, so the first variable will contain a reference to the projectile prefab. We have created a layer. Every time our player fires a projectile, we will create a new instance from this prefab, new game object from this prefab, and the filter variable will be used to filter game objects. Okay, I will explain. I will explain what we have written in projectile shoot ray, and also explain the what is layer mask. Okay, so the another term I am introducing is ray cast. Okay, so there are times in your game when you will need to know if a collider exists in a particular direction. To do this, Unity can cast an invisible ray like this. Unity can cast an invisible ray from a certain point to a direction you specify. Okay, so you will likely encounter a lot of game objects that intersect with the ray. Here I am casting ray from the cube to other object like image, sphere, cone, like that. It will intersect with multiple objects. Okay, so using a mask lets you filter out any unwanted objects. For example, we have to detect whether ray is collided with the sphere or not. Okay, only sphere. Then here it is colliding with image also, here it is colliding with sphere also, and cone also. So to filter out whether it is colliding with sphere or not, we are using raycast. Okay, so raycast are incredibly useful and can used for a variety of purposes. They are commonly used to test if another player has been struck by a projectile or not. But you can also use them to test if there is any geometry underneath a mouse pointer. So there are various application of ray casting, but we are using this ray cast here to check whether we had hit the enemy or not, whether the projectile has hit enemy or not. Okay, so so let's fire our own ray cast. Okay, so in player shooting script, we will create one user defined function void shoot. It will raycast it. It will accept argument raycast it. Okay, we'll create another local variable projectile instantiate. This is the user defined function instantiate, which will create the game object from prefab dynamically. Projectile prefab dot get component projectile, where I will declare another local variable vector point that's new vector 0 this dot transform position that direction Okay. So I have written bunch of code. Let's see. Okay. The first one is I am instantiating the projectile prefab, and I am adding one projectile into the as a game object into the scene dynamically using code. Okay. The second one is a point above floor. This point always looks like x0, y 0.5, and z coordinates, which is also 0. Yeah, these are the coordinates on the floor where the ray cast from the mouse click position hits. This calculation is important because the projectile has to be parallel to the floor. Otherwise, you would be shooting downward. Okay, so we are maintaining our y coordinates, and we are not changing any uh, x or z coordinates. We are maintaining that it shoots parallel to the floor. It will always 0.5, which is height from the floor, and it will maintain always 0.5 from the floor. So it will be parallel to the floor. Okay. Now the direction is direction. Now the third variable direction is from the player game object to point above floor. So we are shooting towards, so we are getting direction on which direction we are shooting the projectile. Now shoot ray variable, it creates a new ray that describes the projectile trajectory by its origin and direction. So we are shooting our ray from this point, from the current point where the player is standing, and we are shooting in the direction which we are uh, figure out using direction variable. Okay, so this is for debug purpose. This is not useful for now. The fifth one is ignore physics.ignore collision. So this line tells Unity's physics engine to ignore collisions between player collider and projectile collider. Okay, so basically what it do, if the projectile is collided with wall, then it will ignore. But if the projectile is collided with the enemy's collider, then it will execute the code. It will enter the own collision enter. Okay, so this is for ignoring the collider of any other object. Okay, and the finally projectile.fire projectile, it sets a trajectory for the projectile because we have to get the direction of shooting the ray. So we will fire projectile in that direction. So we have created a fire projectile function. Okay. Okay. So, but we need to create the trigger. So we will create the trigger on the mouse pointer. Okay. So we will write the mouse click function in the player script. Void sorry, we will write in player shooting only. It will make easier for call. Void raycast on mouse click raycast hit ray to floor camera dot main dot screen point to ray input dot mouse position. If physics dot raycast ray deploy output under convert mask query trigger interaction protocol should. Here in update function, we will detect mouse click, then down, input, get mouse button down, 0. If mouse button down, raycast on mouse click. Okay, so I will explain what it does. The first method, raycast mouse click. This method casts a ray from the camera to the point where mouse is clicked. Then it checks to see if the ray intersect with a game object with a given layer mask. And the second one is update method. The script checks for a left mouse button press. If it finds one, it calls raycast on mouse click. Okay. So here the code is done. We can test it.
Just minute, students. Maybe some issues are there. That's why sir might be there.
So we are done through our script. We can test our game now. Yes, so we will try to run the game. You can see this projectile is firing. And you can kill the enemy. Okay, so let's see fast how we can take the build. So we go to build settings, and I will take the build of Mac OS right now because I am on Mac OS. I will click on build and run, and save my build file. So it will take build a final build of your project or a game. Okay, so it will directly run the build. So this is how you can take a build of a game in Unity, and it will create the one file, build file, in your project folder. You can directly run from it. You don't need to have any Unity editor, or you can just give it to your friends in a pen drive and that's it. Or if you have taken Android build, then you can give it to the if you upload on the Play Store, or if you have taken the iOS build, you can upload on the App Store, and whole world can play your games. Okay, so that's it from my side. If you have any question, you can ask. Okay, so the last part was little bit fast, so because the time is getting over, so I have to speed up the things, and some things I need to I need to explain very slowly to you guys as you are beginner, but I have less time, so I have to speed up the process. But if you have a question, then you can ask, and if you want to ask it later, here is my phone number and email address. You can contact me, and we can discuss in details about your about the problem you are facing in Unity. Thank you guys, and thank you Institute for approaching me to give this seminar. Thank you.
Thank you very much, sir. Now I request student that if you have any kind of question related to Unity 3D or development or career in VR, then please, because sir is the most suitable. Sir is not only expert in Unity 3D, but sir is a entrepreneur also. So if anyone have any kind of such a question, then please ask here. Yes, Kamal, please.
Sir, how to create AR in Unity 3D?
Okay, so AR in Unity 3D, you need to use AR Core SDK. The Android, the Google is providing AR Core SDK, right? Or use Vuforia SDK. These are the two SDK you can use to create AR in Unity 3D. That is the another large subject. I can, if institute chooses, then I can organize another seminar on that one. But you can use these two SDKs or two libraries, and you can create AR applications in Unity.
And sir, another follow-up question, how to create
Yeah.
games in AR?
Sorry.
How to create games in AR?
Okay. Basically, you have to follow this strategy only, right? Basically, what SDKs like Vuforia and AR Code does, it provides you AR camera. Here, what we have done, we have used main camera, which is Unity has provided to us, right? So when you install those SDK in Unity, AR Core or Vuforia, those SDK will provide you the AR camera. You just have to put AR camera in your project or a scene. You have to delete this main camera from Unity camera, and that's it. Other logic will be the same.
Okay, sir, got it. Thank you.
Okay, so basically, if you want to convert this game into the AR, then what you need to do is it's very simple. the core logic will be the same. The collider, shooting, which all things will be the same. You just have to delete the main camera, and you have to put Vuforia camera or AR core camera into the scene, and it will automatically place your arena in front of you on the table on or any surface using AR.
Okay, sir. Got it.
Okay, so anyone else, anything, any kind of interaction, then please quickly. Okay, so sir, thank you very much for giving your valuable time here for our students. And in near future, very soon we will conduct or organize such more events, which is over the AR/VR, because AR/VR is the latest tools technology for nowadays. So thank you very much,
Yes.
sir, for giving your time.
And yes, sir, I would like to also request the institute to organize some workshop with some more time, because
Yes, sir.
these
Now
are the
we
very
we
large subject. Yeah.
we will plan for 3 day workshop now.
Yes, yes, that
Approximately
would
three
be
to
better.
four days. Yeah,
Yes, so
sure,
that
sir.
would be better. So I can
Yeah.
explain the students in very like
Maybe in the end of the March, means the last week of the March, we are going to conduct 3 day workshop in ARVR.
yes, because 3 hours is not enough to
Yes,
cover
I
the
know, sir.
subject.
That is very,
Yeah,
very. You can say that
yeah,
Unity 3D 3 hours is very. You can say very less. We are going
yes.
to, and we are planning also that in the last week of March, 3 day full-fledged workshop,
All right,
6
all
to
right.
7 hour per day.
Okay, looking forward to it.
Yes, yes. Thank you, sir.
Thank
Thank you
you.
very much.
Thank you.
Okay, guys. So, meanwhile, you will receive one mail regarding the feedback, and that will be only sent to the students who are attending the sessions, not to all, only for the student who attend the session. And for other student who did not attend the session, they will also receive the mail, and that mail will be something different. Okay, so thank you very much, guys, for staying here. But only thing is that very less amount of questions were asked. I don't know why, but recording will be provided. Do the practice at the basic level, and we are also planning to conduct 3 day or 4 day workshop, full-fledged workshop on this. That is just for this session was kept so that we can see the intention of the students. So 106 students have attended the session only. So that is also fine for the student side. But those who did not attend, I don't know. We will ask them why they didn't attend. We will mail them to know that why they did not attend. So thank you very much, guys. And whenever you will receive the feedback link from SRM, please fill that. Thank you.
Thank you, sir.